today we're going to spend maybe 20 minutes talking about some more properties of logarithms. We talked about 4 properties of logarithms in lecture 35, which was Wednesday before Thanksgiving break. I posted and I sent everyone an email last week that I posted Project 5 on our Moodle site. You can download it and complete it. It's due a week from, what is today, 2nd, 4th? Week from Wednesday, right, 2/11. Test 3 is on Friday. Today's material, just like in the previous 2 exams, the last material covered, you don't have that full week to do the homework. So today's material will be the last material covered for test 3. So essentially you've had 3 sections, exponential functions 4.1, 4.2, and 4.3 that will be on the next test, and all of chapter 3. So you've had 2 or 3 quizzes on chapter 3 already. So that's really a lot of practice with chapter 3 material. Remember, Caitlin and I posted a ungraded sort of like review on Moodle. You can also use your chapter tests in the book, your mid-chapter tests. You've got lots of stuff to practice. And a study guide should be, did I give you a study guide? That should be posted on Moodle too. If it isn't, I'll post it today. So between all of those things, you should have plenty of problems to work. So let's continue with the properties of logarithms. Remember, logs are just a fancy way of writing exponents. So if you think back to our properties of exponents, then it should make sense when you look at these first, there should be a little bit of a connection between these next 2 properties of logs. For example, this says if you take the log of a product, notice this does not say log b of x times log b of y. It says log base b of the product x times y. So if you think back to your exponent properties of when you're multiplying with the same base, here you have the same base, you add your exponents. And that's what this says. If you have a product and you're trying to simplify it, you take the log of x, log base b of x, and you add it to log base b of y. So what I'd like to do now is just to show you a little proof for those of you who like to see how these things work, okay? This is what mathematicians call a proof, and it's a way of showing that this property works for all values of x and y. And this is, so when you write a proof, one of the ideas here is you want to somehow show how the left side equals the right side or vice versa. Okay, so how I'm going to start, and you don't have to write this down, it's just to show you, but if you like this stuff, go ahead and write it down. So we say let w equal log base b of x, and let z equal log base b of y. Then another way of writing this is that b to the w is equal to x. And another way of writing this, going from log to exponential form, is b to the z equals y. So now I'm going to go back in, and where I see x and y on my left-hand side, I'm going to substitute it with b to the w and b to the z. So log base b of x times y becomes log base b of b to the w, because that's what I'm saying x is, times b to the y. Now I know from my exponent properties that b to the w times b to the y is b to the w plus y. And I know from my properties of logs that log base b of b to the w plus y, the bases are the same. I just lift off my exponent, becomes y plus, oops, that's supposed to be z. Y plus z. And what's y plus, excuse me, I'm talking too fast. Log base b of b to the w times b to the z is log base b of b to the w plus z. Now we know from our log properties from Wednesday that when your bases are the same, this is actually the composition function of your exponential and logs. You just lift off this exponent. Now what did we say w and z were? W is defined right here, is log base b of x, and z is log base b of y. So that proves, and mathematicians do QED, that shows that the log base b of a product is log base b of x plus log base b of y. So one of the things you should try to do in your mind is just to remember logs are exponents. When you multiply exponential forms with the same base, you add exponents, and that's what this property says to do. Okay, you can do a similar proof for this one if you want to try it on your own. If you have log base b of a quotient, remember, think back to exponent rules. When you have a quotient with the same base, you subtract your exponents. And that's what this says to do. You subtract the exponents. Okay? So we're going to be using these throughout today, and you'll have a lot of practice with these. Okay? So you could try this one. Try this, at home when, you're bored. Try proving that one. It's a very similar argument that we did over here. It's almost exactly the same. Okay. Now, look at this one. This says log base b of a power raised to a power, x to the p, of x raised to the p. And this is similar to our exponent property when we have a power raised to a power. And when that happens, the power comes down. Okay, so it's very similar to this. Let's say we have x2 to the fourth, then we have x to the 2 times 4. These two things multiply each other. So what's similar here is that the p comes down in front and multiplies the power, log base b of x. Remember, this is just an exponent. Log base b of x is an exponent. P is an exponent. So you have a power times a power. This is the most useful log property that you're going to be working on once we hit applications. It's the most useful one. So that's the one we'll be using over and over again. Now, for those of you on Wednesday that were curious, how do you evaluate a log that we don't have the base for? For example, if we wanted to say log base 6 of 10, and we pull out our calculator, we realize that we couldn't evaluate that because our calculator only evaluates common log, which is base 10, and the natural log, which is base e. Well, believe it or not, this formula allows us to evaluate on our calculators any log. Okay, so this is called the change of base formula. So no matter what base you have, you can use this formula. And again, you can also use some similar ideas to what I showed you earlier to prove this. So log base b of x, notice we've changed the base. On the left-hand side, the base is b. On the right-hand side, the base is a. So you're going to pick a base that your calculator can use. So a will either be 10 or e will be the natural log, or it will be base 10, the common log. So notice we take log base a of x and we divide it by log base a of this base. So if we were to evaluate this, we could do it this way. Log of 10, notice I didn't put the base in because when I write log, it's understood to be base 10, and log of 6. So if you put that into your calculator, log of 10 divided by log of 6. Oh, I forgot my division. Thank you. Log, that wouldn't really change it, wouldn't it? Log of 10. Oh, now I got way too many parentheses. All right, well, it doesn't matter. Divided by log of 6. And we get 1.285 approximately. Now, it doesn't matter what base you use. That's the interesting thing. You can also say that log base 6 of 10 is equal to the natural log of 10 divided by the natural log of 6. It doesn't matter whether you use common logs or you use natural logs. So let's try that one. Natural log of 10 divided by the natural log of 6. So natural log of 10 divided by natural log of 6. Huh. What did I do? Oh, forgot a parenthesis. Natural log of 10. Boy, I'm really messing up today. It must still be that turkey hangover divided by natural log of 6. There we go. Yeah, that's the turkey. There we go. Same exact answer. So pick your favorite base, and you can use this change of base formula anytime on your calculator. Okay. So again, the only way you can like really remember these properties is to use them. And like I said, you'll have lots of time to use them today. I'm going to give you a very long activity, group activity, but let's do a couple of these together. So here's the instructions. Use the properties of logarithms to combine the following expression. So here's an expression. Log base 4 of 2 plus log base 4 of 32. Now, the first thing you always want to check before you try to use a property is to make sure your bases are the same. So bases are the same, you're good to go. Okay, so you're good to go. Right, so now you said, when do I add? So you say to yourself, well, logs are just exponents. When do I add my exponents? Oh yeah, when I'm multiplying. So log base 4 of 2 plus log base 4 of 32 is equal to, when we combine them, log base 4 of 2 times 32. Okay, and so then you do log base 4 of 2 times 32 is 64. And now you want to write 64 as 4 to some power, so you can just lift off your exponent. Lift off your exponent. So let's write 64 as 4 to some power. What power is 64? 4 to what power? Third. 4 times 4 is 16, times 4 is 64. So now you use the property we talked about in class on Wednesday, and you just lift off that exponent, and there's your answer, 3. So let's do the latter part of our, if you look further down in your notes, it says use your change of base formula, right, to do 2, 3, and 4. So let's use the change of base formula on this to see if we can do it without using this property, change of base formula. So we have log base 4 of 2 and log base 4 of 32. Which base would you like to change to? It's up to you. Natural log, ln, or common log? Doesn't matter, but I'll do whatever you tell me to do for once. Base, the common log? Okay, so log base 10 of 2 divided by log base 10 of 4. And if we add these things, we're supposed to come up with the number 3, right? So now let's use the change of base here. Log base 10 of 32 divided by log base 10 of 4. So I'm changing the base of both of them, and let's see what each of these numbers are. So I go over to my, you can see that it's much easier to use your properties than to go through all this. But let's use the properties. Log of 2 divided by log of 4 equals 0.5. So this whole thing is 1/2. And then let's do log of 32 divided by log of 4. Log of 32 divided by log of 4 is 2.5. 2.5 and a half is 3. So that's how you could use, if you ever forgot the property, you could always use your change of base formula and still come up with the same answer. So what does this tell you? That it says that the log base 4 of 2 is the answer 1/2. And the log base 4 of 32 has the answer 2.5 or 5/2. Okay, that's what it's telling you, that the log base 4 of 2 is 1/2 and log base 4 of 32 is 5/2. And you should be able to check this by using your exponential. This says that your base is 4, and when you raise 4 to the 1/2 power, you come back to 2. And that says 4 to the 1/2 power is the square root of 4, which is 2. That checks. Log base 4 of 32 is supposed to equal 5/2. So let's try that. Our base is 4. Our answer is our exponent. and 32 is the result of that exponential. So let's see what this says. This says take the square root of 4, which is 2, raise it to the 5th power, 32. So they both check. So there's lots of ways with these log properties and problems that you can do them. There's more than one way. The fastest way, and that's part of the reason for these properties, is for efficiency. The fastest way is to take the sum and make it into multiplication problem and then evaluate the log. But again, if you forget, you could always use your change of base formula. So let's take a look at number 3. So here's a problem. It says here, evaluate. So now this is a little different. It's saying evaluate this in 2 different ways. Okay, evaluate means find the value. Can anybody think of one way to do this using any of the properties we've discussed so far? Eric? Of okay, log base 3 of what? Log base 3 of 81 isn't equal to 9. Oh, okay, 9, sorry. Log base 3. Oh, I see, log base 3 of 9 plus log base 3 of 9. So what he did is he said, I'm breaking 81 up into a product, so let me show the intermediate stage that goes right before that this last equal sign. What he did is he said, log base 3 of 81 is 9 times 9. So then he took log base 3 of 9 times 9 and he broke it up into the sum. So now how do we do this? Log base 3 of 9, how do we write that? What's log base 3 of 9? 3, well, 9 is 3 squared, yeah? And then you just lift off your exponent, 2, because 3 squared equals 9, so your answer is 2. So this is 2, so the other answer must be 2, and there's your answer, 4. So what does that tell you? You could have also written this like this. This is the exponent for that base, so I can write 81 as 3 to the 4th. And now I can use my other property. I have a power to a power, so the power comes down in front. 4 times log base 3 of 3, which is 4 times 1, which is 4. So there's 2 different ways to do the same problem. Whatever sort of floats your boat. Okay. In fact, you wouldn't have even needed to use this property because the minute you see this log base 3 of 3 to the 4th, you know you just lift off your exponent because you have the same base. I was just sort of showing you how that property works. So, and then the last one here is use the properties of logarithms. Okay, again, it says evaluate. So you're trying to find the value of this log in 2 different ways. So we have log base 2 of 4 to the 3rd. So let's use our property where we have a power to a power. So the 3 comes out in front, comes out in front of the entire log. Okay. And now we evaluate log base 2 of 4. So you say to yourself, 2 raised to what power gives me 4? Your answer is 2. And there's your answer, 6. Another way to write this would be to get 4 cubed as 2 raised to some power. So off the side of on your paper, you can say 4 is 2 squared. And when you cube that, you get 2 to the 6 because you multiply these 2. And you get 2 to the 6, and you just lift off your exponent. It's another way to do it. Okay. Or, yeah, I would take, yes, most of them you can simplify further. Right. So we just did this one earlier with our calculator. Try these at home with your calculator using your change of base. And really what I'd like you to have a lot of time to do today is just to work on this activity in your group, by yourself, however you choose to work, because you just need to use these properties to get familiar with them. So you have 22 minutes to work on this. Use your flags if you need any help. I'll be glad to help you.